Hey everyone, it's Mrs. Norton and
Mrs. Ryan.
Hey, Mr. Collins.
hey, we're all here to help you be successful with homework 15.6. Okay, the first number that you were supposed to do is number 2B, where you are graphing a compound inequality. Remember, compound just means there's two inequalities working together in some way. Now, how are these working together? Well, look at the word between the two inequalities. What's that word? Yes, it's and. And, what does and mean? Means that both things, y less than 4 and y greater than or equal to 0, have to happen together. So if you remember right, this may look confusing at first because there's so much to look at. Let's break it apart. Let's look at the inequality y is less than 4. Okay. So first we're going to graph the line y equals 4. We're going to think if this is an equation, what if y were equal to 4? Well, I'm going to go to my origin. I'm going to go up my y-axis to 4. 1, 2, 3, 4. So there's where y is 4. And I'm just going to know that if I were to draw a horizontal line across here, that's everywhere that y is equal to 4. But my inequality says less than 4. What do I need to think now? You got it. Should I be drawing a dashed line or a solid line? Well, it's dashed. Why is it dashed? Yep, because it can't include 4. Okay, try to get it straight across here for you. Okay, before we move to the second inequality, we've got one more thing to think about. Remember, and that is, should I be shading above or below? So which is it? Yep, right again. It's got to be below because it says y has to be smaller than 4. And smaller values are going to be down here. Okay. Awesome. Got that so far? I'm going to go pick up another color. Let's do red. We are ready to look at the second inequality. Y is greater than or equal to 0. So again, remember, I'm going to think of this as an equation first and graph y is equal to 0. Well, where is y equal to 0? Right here at the origin. Again, what kind of line am I going to have? Well, it's going to have to be a solid line because it says it could be greater than or it can be equal to 0. So, and it's going to be horizontal because all along this line is where y is equal to 0. Now, how do I shade? What is this saying? Which side has to be bigger? Well, this is saying this side has to be bigger. So y has to be bigger than 0. Well, where is the y value is bigger than 0? Yeah, you guessed it, above the line. Okay, so now, how do we look for our solution in this case? Well, remember, the word and tells me it has to be true in both cases. So we're really looking at the overlap where both inequalities were shaded. Well, where is that? Yep, you got it right in here. Let's get us a different color so we can clearly see where we're shading. Okay. So how do you feel about that, everybody?
I think it's great.
All right, guys, it's Mrs. Ryan. Let's work through your second problem, which was number 2, graph D. And we start with y is less than -5 or y is greater than 5. So the key word to notice here is that or. And or means what? That's right. It means that we're going to be able to include either of those as a part of our solution. It doesn't have to be where they intersect with each other or overlap. Okay, so our first inequality is y is less than -5. So how am I going to begin graphing that? I'm going to think y equal to -5. Where would I put y is equal to -5 on our graph? I would go to my origin and go down the y-axis to -5. Right there. Okay, now I need to decide if I'm supposed to have a dotted line or a solid line. If the inequality is less than, then that's going to be a dotted line because I do not want to include any of the solutions along that line. So I would indicate that to myself by using a dotted line. Bear with me, not the best dotted line I've ever made. Okay, now I have my dotted line. Now I need to decide, am I going to shade the solutions above that line or below that line? The inequality says that I want all the numbers that are less than -5, so those are going to be the numbers below my dotted line. So anything down here. Okay, I'm done with the first inequality. Let's look at the next inequality. We're going to now graph y is greater than 5. Okay, so I need to again think in terms of y equals 5 and where I would graph that. I would go to the origin and go up my y-axis until I reached 5, right here. Okay, is it a dotted line or is it going to be a solid line? Well, again, my inequality is just that it's going to be greater than, so I do not want to be able to include any of the solutions along my line, so it's going to need to be a dotted line to indicate that. All right, now, am I going to shade above that line or below that line? Well, I need values that are going to be larger than 5, so that's going to be anything above this line, so I'll shade that in. Okay, so I've now graphed both of my inequalities, and since the word in between them was or, that means that my solution could be any of these shaded in red, or it could be any of these values shaded in green.
Hey guys, Mr. Collins. Hey, I don't know what this little thing is, but we'll figure that out later. All right, so we want to graph these two equations. So kind of reviewing the steps you guys have used since really the beginning, you have to graph two inequalities separately. So we're dealing with y is less than or equal to -3. But to graph this, we really need to consider the equation version, which would just be y equals 3. So when you're graphing this, you should know a couple things right away. One, there's no slope because it's just a 3 and there's no x part. No slope means a flat line that's horizontal. So let's find 3 on the y-axis. 1, 2, 3. Right. So when you're looking at this inequality, second decision you have to make is this going to be a dashed line or a solid line? Well, if you're looking at it less than or equal, that's going to be a solid line because that's going to be inclusive. So just kind of rule of thumb, and you guys have this kind of all worked out. If you're dealing with these signs, you're dealing with this. You're dealing with these signs, you're dealing with that. So we're certainly going to have a solid line. So let's go to our line tool here. Boom. Line tool. So that's going to be y is equal to -3. This y equals -3. Now, the last decision we have to make, since we actually want y is, whoa, come back. Y is less than or equal to -3 is which way we're going to shade, where our answer is going to be. Well, some of you guys have picked up that less than is going to be below, but if you don't know that, pick a test point.
Mr. Collins, are you doing that on purpose?
What?
Your line should be
Oh. Oops. -3.
Didn't know if you were testing us.
-3. Okay. So we got to pick a test point. Negative. So if you didn't pick up, they had to shade below because a sign, pick a test point. So just pick a y value, like 5. Well, 5 is right here. Is that going to be bigger than 3 or is that going to be less than -3? Or, sorry, bigger than -3 or less than -3? Well, that's definitely not going to be true. That means the shading is not going to be below, above, it's going to be below. So we'll indicate that by this. Okay. Let's go on to number 2. So we're dealing with x is bigger than or equal to -1. So let's go to the equation version. X is equal to -1. Let's find x equals -1 here, and hopefully I got that right this time because I totally jacked it up last time. X is -1. It's going to be a horizontal line because we're dealing with an x equals instead of a y equals. Now let's make a decision on solid or dash. Well, I'm dealing with an inclusive sign, so it's going to be a solid. Let's go red. Vertical going through. Whoa, whoa, whoa. Much better. Okay. That goes to x equals -1. Now, in terms of shading, We want x is bigger than -1, so you might pick up we're shading to the right. If not, pick a test point. Pick an easy one, like 5. Is 5 bigger than or equal to -1? Well, it certainly is. That means it's a good value. We're shading to the right. All right. Now, an interesting question to ask in that asking is where would the answers actually occur? Well, it's because we're dealing with OR, we can't deal with them at the same time. So this area right here is actually a no-go area because that's where it happens at the same exact time. Here it's good because it's only the red. Here it's good when it's only the black. OR is exclusive. That means you got to make a choice. So our solutions would either be in this black shaded region or the red shaded region, but not in between. Cool?
Hey guys, it's me again, Mrs. Norton. So we're going to go on and work on the staying sharp. Yes, we assigned all of it this time. Why did we do that? Well, you guys have a unit test coming up on Monday, and we thought all the problems here were pretty good review. So let's look at number 1. A, find the number that satisfies the inequality x is less than -3. What in the world does the word satisfy mean? Well, guys, it's just a fancy way to say that makes it true. Makes it a true statement versus an inequality that wouldn't make any sense. Now, so we think about less than. That means the x has to be the smaller number, right? And the -3 is the bigger number. So let's think about what could x possibly be. Could it be -2? Well, we really have struggled with this in class, and I keep going back with you guys to the idea of a number line to help you think about this, because we seem to really struggle with knowing what numbers are bigger or smaller when we're talking about negatives. I'm just going to make myself up a number line here. Okay. Not fancy, but there it is. So let's find out where x is -3. Okay, that's right here, right guys? X is -3 right here. So if I want smaller numbers, do I need to look to the left or the right? Yep, you got it. I got to look this way. Okay, so what kind of numbers are less than -3? Well, x could be -4, right? It could be -5. Okay. Could it be -2? Absolutely not. Could it be -3.5? Yep. Okay, so lots of options here, guys, that would make this inequality true. And don't be afraid to use that number line model, especially when you're comparing negatives. Okay, it says check if the number we found in part A also satisfies the inequality -3x is less than 9. I'm going to rewrite that. Okay, so we did some of this in class, guys. I'm just going to pick a real easy one to use from the different solutions I found. I'm going to pick -5. So how do we decide if -5 would also satisfy this inequality? Remember, satisfy just means makes it true. So all I'm going to do is I'm going to replace the variable x with -5 and evaluate this inequality and see what I get. So -3, instead of x, I'm going to put in -5. I know that this means to multiply -3 and -5. And I'm asking, is that, I like to put my little question mark there, truly less than 9? Well, what is -3 times -5? Negative times a negative is a positive, and that's positive 15. Is 15 less than 9? Well, no, it's not. So, does our solution here make this one true? Absolutely not. And that's how we check to see. Then it says, will any number that satisfies x is less than -3 also satisfy -3x being less than 9? And explain. Well, I don't think that there's any number we can choose, because think about it, guys. We are multiplying each side by, we can think of this, let me think about this. This is like me multiplying each side by -3. That's how I think about it. What happens to an inequality? Whoops, that looks really messy, guys. What happens to an inequality when we multiply by a negative number? Yeah, you remember, the sign flips. So this was negative 3x, and this is how this became positive 9. So there's no way with this switching to its opposite that I could ever have a solution to our original inequality, x less than negative 3, be in the solution of negative 3x less than 9, because they'll be opposite numbers. All right. Okay, guys. This is definitely a good review. It's been a while since we've worked a problem like this, and I can guarantee you it's going to show up on the unit test. We're asked to write an equation for a line that passes through the points 3, 5, and 6, 3. In other words, we're asking to write a linear equation, okay, because we have a line, so we're looking for a linear equation. And we're asked to do that if we're given 2 points. Well, guys, what's easy? I'm thinking automatically of writing a linear equation in the form y equals mx plus b. Okay, what information do I need to be able to write this equation? Well, I need the m part, or slope. You know, that rate of change. I also need to find out what b is. Remember, b is the y-intercept. Okay, so I'm going to start out by finding the slope. I know that I can take my 2 points, 3, 5, and 6, 3, and I can use my slope formula, which remember is y2 minus y1 over x2 minus x1. And remember, those little 2's and 1's just represent this y value from my second point, subtract my y value from my first point, all divided by the x value from my second point, subtracting the x value from my first point. So I'm going to go up here and label, like, this is x1, y1, so this will be my first point, and I'm going to call this one my second point, so x sub 2, y sub 2. So now I'm just going to replace my variables with numbers. Y sub 2, that would be this 3, minus my y sub 1 right here, that's my 5, so I got 3 minus 5, over my x sub 2, that's my 6, minus my x sub 1, that would be this 3. Awesome. Okay, now just do the math. 3 minus 5, well, that's negative 2. Don't let that negative get you. And 6 minus 3 is 3. So my slope is negative 2/3. And I'm going to leave it just like that, guys. I'm leaving it as a fraction because it'll be more accurate. So now I know part of my equation. Y equals negative 2/3 x plus whatever, plus the y-intercept. So what do I still need to find out? Well, I still need to find out what my y-intercept is. So this is where I go back and I'll use one of my points, either 3, 5 or 6, 3, and plug in those points for my x and y and solve for b. I'm going to choose to use the point 6, 3. Bring it down here. So all I'm going to do is replace the x with 6 and the y with 3. So this will be 3 equals negative 2/3 times 6 plus b. Okay, doing the math, first thing I'm going to do is negative 2/3 times 6. I can punch that into my calculator, leaving this as even as a fraction. Remember, I can put this in parentheses. And I know this is going to be negative 4 plus b, and I have 3 over here. Well, now this is pretty simple undoing. Negative 4 plus b equals 3. I'm going to add 4 to each side. Oop. 3 plus 4 is 7 equals negative 4 plus 4, that's gone. So b equals 7. I just found my y-intercept. So now I'm going to put my y-intercept into my equation. And my equation is y equals negative 2/3 x plus 7. Voila. And that's how I write an equation for a line that goes through 2 points.
All right, so we got to solve this thing by using a table. It's a very cleverly disguised problem, but let me write down here what this problem actually looked like. So they'd ask you to solve by table 4x plus 18 is equal to negative 2x plus 6. And we know how to actually decode this and really kind of attack it using a table. You know, step one is always to break this up into 2 equations. The y1 is equal to 4x plus 18, and with the y2 being equal to negative 2x plus 6. We're going to put that in, what we've done in class is really just put that into our calculators to help us generate the table. So I say, why not do that here as well? I mean, there's no point in having technology not using it. So whoop, magic of computers. I have a calculator here as well. So I cleared it. You guys know how to clear it. 2 plus 7, 1, 2. And then I'm going to go to my y equals and enter my 2 equations. So I got the 4x plus 18. And then I have the negative 2x plus 6. Okay, so I have my 2 equations from the original. Reading the problem is really just like left-hand and right-hand equations. I put them in my calculator. Let's look at the table. Now, they specifically want us to look between negative 3 and 3, so I'm going to go ahead and arrow up so I can see those values. And just kind of fill in what I see. So just to make sure that I'm on the right one, y1 is going to be the 4x minus 18, which that's going to be my first column. The y2 is going to be the 2x minus 6, or plus 6, excuse me, which is going to be my second column. So just copying these values down, I have 6, 12, 10, 10, 14, 8. You know what? I don't even think I need my table anymore, because if I know how to read these equations, I should be pretty good. That's my slope. That's a 4. That means I'm going up 4 every time. And look at this. Plus 4 plus 4. That'd be 18. That'd be 22. Plus 4 is 26. And that'd give me a 30. Likewise, over here, I have a minus 2 for my slope. It means I'm going down by 2 each time. So it's minus 2, 4, 2, 0, minus 2. We can also confirm by looking at the y-intercepts. That's going to be at 18. Hey, look at that. And that's going to be a 6. How come that wasn't 6? Oh, because I didn't subtract 2 each time. Whoops. And we're back. 8, 6, 4, 2, 0. Which is why you should always check your work. There you go. So I got the table for each function. Now let's actually get to the real question, which is, where's the answer? Well, the answer graphically is going to be where they cross. It's going to be where one line and the other intersect, which is going to be, it looks like about right here. So if you're looking at the intersection, looking at the solution, you're looking at where the thing's crossing, which means it's where they're the same. So let's look in this tail value, see if we can see where they're the same. Well, not the same there. Whoa, yellow, thanks. Oh, look at that. That's where they're the same. So we have some like values, which means we're really looking for this answer of negative 2. I'm not going to write out that whole thing I just kind of talked through, but that's the whole deal. If you're looking at a table for solutions, you want to be where they're the same, because, well, that's where the answer is graphically. And if you really want to, whoa, hey, look at that, that's kind of cool. Anyway, and if you want to know where the original equation, well, that's what this symbol means right here. Well, I kind of missed on that, didn't I? Let's try it again. That's what this symbol means right there. Equality. Equality means the same. Where they intersect, where they are, the table value is the same. It's all the same thing. It's not a big deal, right? All right, so here, let's finish this up. Let's see if we can get this under 30 minutes here for this video. We have a line passing to point 2, 3 with a slope of negative 2 graphed on the grid. Well, we need 2 points. I mean, to graph a straight line, we need 2 points. So let's start 2, 3. Boom, 1, 2, 1, 2, 3. So all we really have to generate is a second point. We're told the slope of 2. Well, let's break down what that means. If I'm dealing with a slope of negative 2, we know that's going to be the change in y over change in x. Well, the change in y, change in x is a fraction. So let's make this a fraction also. So think of a number I can put down here so that the value itself doesn't change. Well, that's going to be a 1, which also equates to my rise and run. These are all equivalent things. Either way, that if I'm going to use -2, whether I look at it as change in y over change next or rise over run, it's going to get me to my next point. This tells me to change in y2 values, which -2 means go down, boom, boom, run 1, there's my second point. And I can do this again to confirm it's linear, down 2 and over 1, down 2 and over 1, and I can even kind of go backwards. So I can go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Either way, we can see they're all going to line up linear, slope of -2, passing to 2, 3. Let's put a line on this. Let's go green. Look at that. That was awesome. I really meant it to go there. Okay. Over here, they want us to write the Okay. Over here, they want us to write the equation. Well, guys, we're half done. We already established it's linear. We already established what the slope is. All we really need is a y-intercept because, well, we're dealing with y equals mx plus b. Okay. Mx plus b, that's going to be your slope. That's going to be your y-intercept. So we already have it partially written because we know the slope is going to be a -2. We just have to figure out y-intercept, which is where it crosses the y-axis. It looks like it's going to cross here. In fact, we confirm that by counting up 2 over 1, up 2 over 1. That's going to be at 7. So we're looking at a plus 7. Okay, so there you have it. Y equals -2x plus 7. The -2 came from actually given information. The plus 7 came from actually counting backwards, so it hit the y-intercept. All right, so that's what we got for this video. Hope it helped. So you guys have a test coming up, so don't forget about that. These are great review problems. So this helped. Why don't you tell someone about it, get them to watch it, get them to be doing their homework, because, you know, it's not really fair. You're the only one doing it. So that's Mr. Collins saying goodbye.
See ya. Good luck.
All right, see you guys tomorrow.